Hi guys, Stack Lessons here, another 20-question session for you, this one centered on shared responsibility model, fault tolerance versus high availability, and large-scale data migration. Same format as always: question, countdown, answer, explanation. Pause anywhere you need to think. Enjoy. Time for another one. Question 1. Every phrase counts. Conteso Logistics is migrating its warehouse management system to AWS. The application runs on a self-managed Oracle database and a custom Java application server. The migration team has been asked to move the database tier to Amazon RDS for Oracle, which handles patching, automated backups, and multi-as replication automatically, while keeping the Java application code completely unchanged. Which of the 7 rupees of migration best describes this approach? Select one. Review the answer choices on screen. The correct answer is option A. Code unchanged doesn't mean no cloud benefit added. Re-platform, sometimes called lift, tinker and shift, describes migrating to the cloud while making a limited set of targeted optimizations to benefit from managed services, without changing the core application architecture or code. Moving a self-managed Oracle database to Amazon RDS for Oracle is the canonical re-platform example. The application still uses Oracle. The Java application code is completely unchanged, but the database now benefits from AWS managed patching, automated backups, and multi-as replication. The team took advantage of a managed service without redesigning anything. Rehost describes moving an application to the cloud with 0 changes. If the Oracle database were migrated onto an EC2 instance still running Oracle in a self-managed configuration, that would be a rehost. Refactor or re-architect involves fundamentally redesigning the application to use cloud-native patterns, such as microservices, serverless compute, or purpose-built databases. It requires significant code and architecture changes well beyond what is described here. Repurchase means replacing the existing application with a commercial SaaS alternative from a third-party vendor, such as switching from a custom-built warehouse system to a pre-packaged SaaS WMS product, which is not the case in this scenario. Time for another one. Question 2. Avoid the familiar but wrong answer. Van Arsdale Limited operates a popular online gaming platform that has experienced repeated volumetric DDoS attacks targeting their application load balancers. Their platform currently uses AWS Shield Standard. The security team wants to add 24/7 access to the AWS DDoS response team during active attacks, and receive financial protection against AWS scaling charges that result from DDoS-generated traffic. Which option meets these requirements? Select one. Review the answer choices on screen. The correct answer is option D. 2 features only Shield Advanced can deliver. AWS Shield Advanced provides all capabilities included in Shield Standard, and adds dedicated 24/7 access to the AWS DDoS Response Team, DRT, which can be engaged during active attacks to apply custom mitigations. It also includes cost protection. AWS credits scaling charges on protected resources such as elastic load balancing, EC2, CloudFront, and Route 53 that are triggered by DDoS-generated traffic, directly addressing the financial exposure concern. AWS WAF applies rule-based filtering at the application layer, Layer 7, and is designed to block web exploits such as SQL injection, cross-site scripting, and bad bots. It does not mitigate volumetric network and transport layer, Layer 3 and 4, DDoS floods. Amazon Guard Duty detects malicious or anomalous activity by analyzing logs and threat intelligence feeds, but it is a detection and alerting service and does not block or absorb in-progress DDoS traffic. Amazon Inspector performs automated vulnerability assessments against EC2 instances and container images to identify software vulnerabilities. It has no capability to detect or protect against DDoS attacks. Ready. Question 3. Convert the story into selection criteria. Fabricum Fintech is building a real-time payment authorization service that stores session state for in-flight transactions using Redis commands. Session data must be accessible in sub-millisecond latency. The critical requirement is that session data for active transactions must survive a node failure without any data loss, because losing transaction state could result in duplicate charges or incorrect account balances. Which AWS service should the architect select? Select one. Review the answer choices on screen. The correct answer is option C. ElastiCache feels right. Here's the critical durability gap. Amazon Memory DB for Redis is a durable, Redis-compatible in-memory database that persists all data to a distributed multi-as-transaction log, ensuring zero data loss in the event of a node failure. Because Memory DB is architected as a database rather than a cache, it provides the strong durability guarantees required for financial transaction state, where any data loss would cause incorrect charges or balance errors. Amazon ElastiCache for Redis is an in-memory caching service optimized for performance but not durability. It does not guarantee that cache data survives node failures, and it is explicitly positioned as a layer where occasional data loss is acceptable in exchange for speed. While ElastiCache offers optional Redis persistence features, its architecture and operational model are designed for workloads that tolerate data loss. Amazon DynamoDB delivers consistent single-digit millisecond latency and full durability, but it operates at millisecond range latency rather than sub-millisecond, and it does not provide the Redis API compatibility required if the application is built on Redis data structures and commands. Amazon RDS for PostgreSQL with multi-as provides strong durability through synchronous replication to a standby instance, but it uses disk-based storage and operates at latencies of several milliseconds, making it unsuitable for the sub-millisecond access requirement. Let's slow down here. ElastiCache and MemoryDB look nearly identical, but one of them can lose your money. Imagine your payment app tracks in-flight transactions in Redis, say 50,000 active sessions at once. Now a node crashes. With ElastiCache for Redis, that in-memory data can vanish. There's no zero-loss guarantee built in. Charging a customer twice is not an option. MemoryDB for Redis looks the same from your app, same Redis API, same sub-millisecond reads, but every write is confirmed by a multi-as transaction log before your app gets an OK. A node crash loses nothing. The trap: ElastiCache has optional persistence, but it only shrinks the loss window, it doesn't close it. For session state that controls money movement, only MemoryDB gives you the durability. That's why C wins. Let us switch gears. Question 4. Test each option against the full ask. A solutions architect is selecting storage for 3 distinct use cases on AWS: a relational database running on a single EC2 instance that requires block-level storage with consistent low-latency IOPS, a shared home directory that must be mounted simultaneously by dozens of Linux EC2 instances in the same VPC, and a static website's image assets that must be publicly accessible over HTTP. Which combination of services should the architect use? Select 3. Review the answer choices on screen. The correct answers are option A, option C, and option E. Match each use case before you touch the answers. Amazon EBS provides block-level storage that attaches to an EC2 instance and delivers the consistent, low-latency IOPS that relational database engines require for random read and write operations. EBS volumes are designed for single-instance attachment with predictable disk-level performance. Amazon EFS provides a fully managed NFS file system that scales automatically and can be mounted concurrently by thousands of EC2 instances, making it the correct choice for a shared home directory accessible across multiple Linux instances without any capacity planning. Amazon S3 provides object storage with native HTTP access, built-in static website hosting, and virtually unlimited scale, making it ideal for serving image assets publicly over the web. S3 is unsuitable for relational databases because it is an object store without block-level access or the low-latency random I/O that database engines require. EBS is unsuitable for the shared directory because a standard EBS volume can only be attached to a single EC2 instance at a time, making simultaneous multi-instance access impossible. EFS is unsuitable for public HTTP serving because it is a private network file system accessible only within a VPC, not from the public internet. 3 use cases, 3 different storage services. Let's match each one to the right tool. Imagine you're setting up 3 things at once: a database, a shared home folder for 50 Linux servers, and a website image gallery. Each needs a different storage type. Ask yourself one question at a time. Need fast, low-latency disk access on a single server? That's your relational database. Use EBS. Need the same folder mounted on many servers simultaneously? That's your shared home directory. Use EFS, the network file system. Need files served publicly over HTTP? That's your image gallery. Use S3. The trap: EBS attaches to one instance only, so it can't be shared. S3 has no block-level disk access, so databases can't run on it. Match the pattern to the service. Keep your focus here. Question 5. Picture the scenario first. Northwind Manufacturing has 600 terabytes of historical production data stored in its on-premises data center that must be migrated to Amazon S3. The company's shared internet connection runs at 100 megabits per second and supports all business operations during the day. The IT team estimates a full online transfer would take well over a year at available bandwidth. The company must complete the migration within 2 months. Which AWS service should they use to perform this data transfer? Select one. Review the answer choices on screen. The correct answer is option D. One rule cuts through every bandwidth calculation. AWS Snowball Edge is a physical data transfer appliance that AWS ships to the customer's location. Customers load data onto the device locally at full LAN speeds, and then return the device to AWS, which imports the data directly into Amazon S3. Each Snowball Edge storage-optimized device holds up to 80 terabytes of usable storage, so the 600 terabytes migration can be completed using multiple devices in parallel within the 2-month window without consuming any internet bandwidth. A widely used guideline is that if an online network transfer would take more than 1 week, physical transfer via AWS Snow family devices is the recommended approach. AWS Data Sync accelerates and automates online file transfers to AWS storage services, but it is entirely constrained by available network bandwidth. At 100 megabits per second shared across active business operations, the practical throughput available for migration is far too low to transfer 600 terabytes in 2 months. AWS Direct Connect establishes a dedicated, high-bandwidth private connection to AWS, but procuring and provisioning a Direct Connect connection takes weeks, and even a high-bandwidth connection may not sustain throughput sufficient to complete the migration on deadline. AWS Storage Gateway is a hybrid storage integration service that bridges on-premises environments with AWS cloud storage for ongoing use cases. It is not designed for bulk one-time data migration at petabyte scale. We've seen the replatform rehost line, why MemoryDB beats Elasticache for financial data, and when offline shipping beats any network transfer. Keep your focus here. Question 6. The condition is doing work. A solutions architect at Northwind Manufacturing is designing recovery strategies for 2 workloads. The order management database accepts a maximum of 60 seconds of automatic failover time, after which normal operations resume. The real-time payment authorization system, however, must process every transaction without any interruption whatsoever, even if a component fails simultaneously. Which statement correctly maps each workload to its required availability strategy? Select one. Review the answer choices on screen. The correct answer is option B. Zero interruption. Two words that name only one answer. High availability means the system minimizes downtime and recovers quickly from failures, but a brief interruption during failover is acceptable. A 60-second automatic recovery window, such as Amazon RDS Multi as promoting a standby replica after a primary failure, is a classic high availability pattern. Fault tolerance means the system continues operating with zero interruption, even when a component fails, achieved through redundant active-active configurations that absorb failures transparently and without service interruption. The payment authorization system's requirement of zero interruption under any failure defines fault tolerance, which requires architecturally more complex and more expensive redundancy than high availability. High availability and fault tolerance are distinct strategies with different cost profiles, not simply different points on the same uptime scale. Let's pause here. HA and fault tolerance sound alike, but the exam tests whether you know the real difference. Imagine grading two contracts side by side. One says we'll recover within 60 seconds, the other says we will never stop, no matter what breaks. Those are completely different promises. The phrase maximum of 60 seconds tells you a brief outage is acceptable, that's high availability. Amazon RDS Multi as is the classic example, the standby promotes, but you do lose those seconds, then spot without any interruption whatsoever. That's the exam signal for fault tolerance. Zero interruption, even during simultaneous failures, means redundant active components running in parallel. The question rewards reading every qualifier, not just skimming the last sentence. All right, question 7. Eliminate before you select. A cloud architect at Fabricam Corp is reviewing the company's AWS environment against all 6 pillars of the AWS well-architected framework and must make recommendations specifically for the sustainability pillar. Which 2 practices align with the sustainability pillar? Select 2. Review the answer choices on screen. The correct answers are option A and option C. Ask only. Does this actually reduce energy consumption? The sustainability pillar of the AWS well-architected framework focuses on minimizing the environmental impact of running cloud workloads. Selecting regions with higher renewable energy availability directly reduces the carbon footprint of workloads by ensuring the underlying infrastructure runs on cleaner energy sources. Right-sizing instances and stopping idle resources reduces unnecessary energy consumption, which is a core sustainability practice that benefits both the environment and operational cost. Purchasing reserved instances is a cost optimization practice that reduces per-unit spending through capacity commitments, but does not reduce energy usage or environmental impact. Enabling Cloud Trail is a security and operational excellence practice focused on auditing and governance, not environmental efficiency. Storing compliance documentation in AWS Artifact is a compliance and governance activity that falls under the security pillar, not sustainability. All right, question 8. Map the qualifier to the answer. Northwind Traders is a financial services firm subject to regulatory compliance requirements specifying that encryption keys must reside on dedicated single-tenant hardware security modules. The compliance mandate also states that AWS personnel must have zero access to the cryptographic key material at any time. Which AWS service satisfies both of these requirements? Select one. Review the answer choices on screen. The correct answer is option B. Dedicated single-tenant hardware disqualifies KMS immediately. AWS Cloud HSM provides dedicated, single-tenant hardware security modules housed in AWS data centers. Each Cloud HSM cluster is exclusively allocated to the customer, and AWS has no access to any keys or data stored inside the cluster. Customers generate and manage their own cryptographic key material on dedicated hardware. Cloud HSM meets FIPS 142 Level 3 requirements demanded by financial services and other regulated industries. AWS Key Management Service, with customer-managed keys, operates on multi-tenant infrastructure managed by AWS. While customers control key usage policies, the underlying HSMs are shared infrastructure, and AWS retains administrative access to that infrastructure, meaning this does not meet the requirement for dedicated hardware with zero AWS key material access. AWS Secrets Manager is designed for storing application credentials, API keys, and database passwords, and does not provide dedicated HSM hardware or cryptographic key management for data encryption. AWS Certificate Manager manages SSL/TLS certificates and can operate a private certificate authority, but it does not offer dedicated HSM key storage or the granular cryptographic control required by this compliance mandate. Okay, let's read question 9. A Datum Retail is launching a limited-time flash sale campaign. The website is expected to receive traffic ranging from near-zero requests between sales to bursts of up to 40,000 requests per second during the 45-minute sale window. The engineering team wants to minimize operational overhead and eliminate compute costs during idle periods between campaigns. Which AWS compute service is best suited for this workload profile? Select one. Review the answer choices on screen. The correct answer is option A. Zero cost at zero traffic, only one service fits. AWS Lambda is the ideal solution for this workload profile. Lambda scales automatically from 0 to tens of thousands of concurrent executions within seconds in response to incoming requests, and it bills only for actual compute time consumed during invocation. There are no charges when the function is not executing. This combination of automatic per-request scaling and zero-cost idle time directly satisfies both the extreme traffic variability and the cost elimination requirement between campaigns. Amazon EC2 with auto-scaling handles variable traffic, but has a warm-up delay as new instances launch and bootstrap, which may be too slow for sudden 40,000 request per second spikes, and instances incur charges even while scaling decisions are pending. Amazon ECS with the Fargate launch type provides serverless container execution with task-level scaling, but has slightly longer startup latency than Lambda, and is better suited for longer-running, containerized services rather than short event-driven functions with extreme burst variability. Amazon Lightsail provides simplified fixed-price virtual servers designed for steady and predictable workloads. It has no automatic scaling capability, and would be massively over-provisioned during idle periods and under-provisioned during peak traffic. Okay, here's question 10. Fabricom Solutions currently runs a MySQL database on a self-managed Amazon EC2 instance. The team performs all database administration tasks, including applying operating system security patches and upgrading the MySQL engine version. The company migrates the database to Amazon RDS for MySQL. Which responsibility shifts from the customer to AWS after this migration? Select one. Review the answer choices on screen. The correct answer is option C. Exactly one responsibility shifts when you move to RDS. Amazon RDS is a managed database service. When a team migrates from a self-managed MySQL database on EC2 to Amazon RDS, AWS takes over responsibility for patching and maintaining both the underlying operating system and the MySQL database engine. On EC2, the customer owns the guest OS entirely, which includes applying OS security updates and upgrading the database software. With RDS, AWS performs these maintenance tasks automatically during configurable maintenance windows, which is a core operational benefit of using managed services. The customer remains responsible for encrypting and classifying their own data regardless of service type, as data ownership never transfers to AWS under the shared responsibility model. Security group configuration to control network access to the RDS instance remains a customer responsibility, because customers define what traffic is permitted to reach their resources. Database user account management, including creating users and assigning privileges within the database engine, also remains entirely under customer control. The HA versus fault tolerance distinction, Cloud HSM's single tenant advantage over KMS, and the one-task RDS takes completely off your plate. Here we go. Question 11. This is a two-step filter. A company runs workloads on AWS using two different service models, Amazon EC2 instances for its application tier, and Amazon DynamoDB for its data tier. The security team is reviewing the division of responsibilities under the AWS shared responsibility model. Which two responsibilities remain with the customer across both service models? Select 2. Review the answer choices on screen. The correct answers are option B and option D. Both answers must hold for EC2 and DynamoDB simultaneously. Under the AWS shared responsibility model, managing IAM permissions and access policies is always the customer's responsibility regardless of service type. Customers must define who can access which resources, grant least privilege permissions, and audit access controls whether they are using IaaS services like EC2 or fully managed services like DynamoDB. Protecting customer data by deciding whether to enable encryption at rest and in transit is also always the customer's responsibility. AWS provides encryption tools and capabilities, but the decision to apply encryption and how to classify data belongs to the customer for every service type. AWS manages the physical host operating system and hypervisor for both EC2, the bare metal layer below the customer's guest OS, and DynamoDB. For DynamoDB, AWS manages all database engine patching as part of the fully managed service. For EC2, the customer patches the guest OS but not the host. Physical network hardware inside AWS data centers is always managed exclusively by AWS as part of its infrastructure responsibility. Let's pause here. The shared responsibility model has real traps, and this question tests two of them. Think of AWS like a hotel. They own the building, the plumbing, the locks on the front door. But they don't decide who gets a key to your room. That's on you. Same deal on AWS. Say you have a DynamoDB table with 5 million customer records. AWS patches the database engine. But who can query that table? Is that data encrypted at rest? That's still your call. IAM policies are yours. Encryption decisions are yours. AWS gives you the tools. You have to choose to use them. The trap here is thinking fully managed means AWS handles your security. It doesn't. DynamoDB is managed. AWS patches the engine. But B and D are always the customer's job, no matter the service model. Here we go. Question 12. Choose for this case, not every case. Fabricam Media has 500 terabytes of archived video content stored on premises that must be migrated to Amazon S3. The company's dedicated internet connection provides 1 gigabit per second of bandwidth. A network analysis shows that transferring all 500 terabytes over the existing connection would take approximately 45 days. The project timeline requires the migration to complete within 2 weeks. Which AWS service should the team use to meet this deadline? Select 1. Review the answer choices on screen. The correct answer is option D. 45 days online, 2-week deadline. offline wins. AWS Snowball Edge is a physical data transfer device designed for large-scale offline migrations. AWS ships the device to the customer's facility, data is loaded locally at full local network speeds, and the device is shipped back to AWS for ingestion into Amazon S3. For 500 terabytes of data, multiple Snowball Edge devices can complete the migration well within a 2-week window, bypassing the internet bandwidth bottleneck entirely. AWS data sync over the existing internet connection is still constrained by the 1 gigabit per second bandwidth limit and cannot transfer 500 terabytes within 2 weeks, regardless of parallelism. Upgrading to Direct Connect at 10 gigabits per second could reduce transfer time, but provisioning a new circuit takes weeks and even at full utilization would require over 100 hours, making the 2-week deadline operationally risky. Amazon S3 Transfer Acceleration optimizes upload performance over long geographic distances using CloudFront edge locations, but the bottleneck here is the internet circuit bandwidth, which transfer acceleration cannot overcome. Here we go. Question 13. Coming up, Conteso Healthcare stores patient MRI scans in Amazon S3. Scans are accessed frequently during the first 30 days after creation but are rarely accessed afterward. The radiology team requires that all scans remain instantly retrievable at any time. The company wants the most cost-effective solution that automatically moves data to cheaper storage without manual intervention. Which S3 storage class should they use? Select one. Review the answer choices on screen. The correct answer is option B. Auto-tiering, no retrieval fee, no manual lifecycle rule. S3 Intelligent Tiering automatically monitors object access patterns and moves objects between a frequent access tier and an infrequent access tier without retrieval fees or operational overhead. Both tiers provide millisecond retrieval, satisfying the immediate availability requirement. This makes it ideal when access patterns shift over time without requiring manual lifecycle rules. S3 Standard provides high-performance access for frequently accessed data, but does not automatically move data to cheaper tiers as access declines. S3 Standard Infrequent Access provides immediate retrieval, but requires manually configured lifecycle policies and charges per gigabyte retrieval fees, adding cost complexity. S3 Glacier Instant Retrieval is designed for archive data accessed roughly once per quarter, and, while it does provide millisecond retrieval, its cost structure is optimized for data accessed far less frequently than the first 30 days described. Next up, question 14. Check the condition before the service. Lambda Healthcare is building an intake processing system that extracts structured information from scanned medical forms. The documents contain a mix of handwritten patient responses and printed form fields, and the system must automatically identify form fields, checkboxes, and tables to populate a downstream database. Which AWS AI service should they use? Select one. Review the answer choices on screen. The correct answer is option C. Comprehend reads text, Textract finds text inside images. Amazon Textract is an AI service that automatically extracts text, handwriting, and structured data from scanned documents. Beyond basic OCR, Textract understands document structure and context. It identifies form fields, checkboxes, tables, and key value pairs from both printed text and handwritten content in images and PDFs. This makes it well suited for processing medical intake forms that combine handwritten patient responses with printed form elements. Amazon Comprehend is a natural language processing service that performs sentiment analysis, entity recognition, key phrase extraction, and topic modeling on text that has already been extracted. It cannot process raw scanned images or identify form structure. Amazon Transcribe converts spoken audio into written text and is designed for voice recording transcription, not for extracting structured data from document images. Amazon Recognition analyses images and videos for object detection, facial recognition, content moderation, and scene classification. It does not extract structured form data or understand document layout and field relationships. Now, question 15. Watch the almost right choices. The cloud finance team at Northwind Corp has three distinct needs. A manager needs to estimate monthly costs for a new workload before any resources are provisioned. A FinOps engineer needs to analyze and visualize last month's actual spending broken down by AWS service and cost allocation tag. And the team needs an automated email alert when EC2 spending exceeds $5,000 in any calendar month. Which combination of AWS tools addresses all three needs? Select 3. Review the answer choices on screen. The correct answers are Option A, Option C, and Option F. 3 jobs, 3 tools, don't cross the wires. AWS Pricing Calculator is a free web-based planning tool that allows teams to model new AWS workloads and generate estimated monthly cost breakdowns before any resources are deployed, supporting configuration of specific instance types, storage volumes, data transfer, and dozens of other service parameters. AWS Cost Explorer provides an interactive console for visualizing and analyzing historical and current AWS spending, with flexible filtering and grouping by service, linked account, usage type, and cost allocation tag, making it the correct tool for ad hoc analysis of last month's actual spending without requiring additional data pipeline setup. AWS Budgets enables teams to define custom cost, usage, and reservation thresholds and receive automated notifications by email or Amazon SNS when actual or forecasted spending approaches or exceeds those limits, directly meeting the EC2 monthly alert requirement with purpose-built threshold management. AWS Trusted Advisor analyses existing deployed resources across cost, performance, security, and fault-tolerance dimensions and flags optimization opportunities. It does not generate cost estimates for new workloads that have not yet been deployed. Amazon CloudWatch monitors operational and infrastructure metrics, including CPU utilization, network throughput, and latency. While billing metrics exist in CloudWatch, AWS Budgets is the purpose-built and far simpler tool for cost threshold alerting and requires no custom metric configuration. AWS Cost and Usage Report delivers the most granular raw billing data available as CSV files delivered to an S3 bucket, intended for processing with tools such as Amazon Athena or QuickSight. It does not provide an interactive ad hoc analysis interface and requires a data pipeline to derive monthly service-level summaries. Let's slow down here. This one tests whether you know which cost tool does which specific job. Imagine your finance team has 3 jobs this week. Estimate costs before building anything. Find out where last month's money actually went, and get an email the moment EC2 spending hits $5,000. For estimation, use AWS Pricing Calculator, not Trusted Advisor. Trusted Advisor only scores resources you already have running. For historical analysis, use Cost Explorer. It's an interactive chart you open in the console. The Cost and Usage Report drops raw CSV files into S3. You'd need a data pipeline just to read it. For alerts, use AWS Budgets. CloudWatch can alert on billing, but you'd have to wire up custom metrics yourself. That's the trap. 3 tools, 3 jobs, 1 right answer each. Shared responsibility answers must cover every named service, and the 3 cost tools each own exactly 1 distinct job. Let us keep moving. Question 16. One answer is too broad. Fabricam Corp hosts a multi-tier application using Amazon EC2 instances for compute and Amazon S3 for object storage. The security team is conducting a shared responsibility audit to clarify which responsibilities belong exclusively to Fabricam versus those managed by AWS. Which 2 security tasks are Fabricam's responsibility for both Amazon EC2 and Amazon S3? Select 2. Review the answer choices on screen. The correct answers are option B and option D. Only select what applies equally to both named services. IAM policies are always the customer's responsibility regardless of service type, whether using EC2, S3, DynamoDB, or any other AWS service. Defining which users and roles can access resources belongs exclusively to the customer. Data classification and encryption configuration are also always the customer's responsibility. AWS provides encryption tools such as KMS, but the decision of what to encrypt, how to classify data, and which encryption keys to use rests with the customer for every service type. Patching the guest operating system applies only to EC2 as an IaaS service, not to S3, which is a fully managed abstracted service where AWS handles all OS-level patching. Physical data center security is always AWS's responsibility across all service types. The underlying host OS beneath EC2 hypervisors is AWS's responsibility, not the customer's. Let us keep moving. Let's check question 17. Meridian Healthcare is implementing an encryption solution for protected health information, PHI. The compliance team requires dedicated single-tenant hardware security modules that only Meridian staff can access and administer. Which AWS service should they use? Select one. Review the answer choices on screen. The correct answer is option B. Dedicated +0 AWS access narrows it to one service. AWS Cloud HSM provides dedicated, single-tenant hardware security modules where the customer has exclusive administrative access. Customers control and manage their own encryption keys within hardware that no AWS personnel can access. AWS Key Management Service uses shared, multi-tenant infrastructure managed by AWS, meaning AWS has a role in administering the underlying hardware. Secrets Manager is designed for storing and rotating secrets such as API keys and database passwords, not for providing dedicated HSM hardware. AWS Certificate Manager manages SSL/TLS certificates for use with AWS services, and does not provide general-purpose cryptographic key management in dedicated hardware. Let us keep moving. We're on question 18. Northwind Corporation is planning a large-scale migration to AWS. During the readiness assessment, the cloud team identifies that employees lack the skills to operate cloud infrastructure, that the organizational structure needs to evolve from a siloed IT department to cross-functional cloud teams, and that leaders need to champion the cultural transformation required for adoption. Which AWS Cloud Adoption Framework perspective addresses these organizational and human capital challenges? Select one. Review the answer choices on screen. The correct answer is option A. Skills gaps and org change belong to one CAF lens. The people perspective of the AWS Cloud Adoption Framework focuses on the human capital and organizational capabilities required for cloud adoption. It addresses culture and organizational structure, resource management, training and skills development, leadership alignment, and organizational change management. When a company identifies that employees need cloud skills, that the org structure needs to evolve toward cross-functional teams, and that leadership must champion a cultural shift, these are precisely the capabilities the people perspective targets. The governance perspective addresses audit and compliance, risk management, portfolio management, and business process governance, the structural guardrails for decision-making. The operations perspective covers IT service delivery, application management, infrastructure management, and incident management, how day-to-day services are run after adoption. The business perspective focuses on business case development, financial management, and aligning cloud investments to measurable business outcomes, typically at the CFO and CEO level. Time for another one. Question 19. Prioritize the stated requirement. Tailspin Toys runs batch processing jobs on Amazon EC2 instances located in private subnets within a VPC. During job startup, the instances must download software dependency packages from public repositories on the Internet. The instances must not be directly reachable from the Internet at any time. Which VPC component enables this outbound-only Internet connectivity for the private EC2 instances? Select one. Review the answer choices on screen. The correct answer is option C. Outbound only, never inbound reachable, one architecture fits. A NAT gateway deployed in a public subnet allows EC2 instances in private subnets to initiate outbound connections to the Internet while blocking all unsolicited inbound connections from external sources. The private subnet route table is configured to send Internet-bound traffic to the NAD gateway, which forwards requests through the VPC's Internet gateway using the NAD gateway's elastic IP address. Response traffic flows back through the NAD gateway to the originating private instance, but no external entity can initiate a connection to the private instances directly. An Internet gateway enables two-way Internet connectivity but cannot be used to give private subnet instances Internet access. Private subnet instances lack public IP addresses and their route tables do not reference the Internet gateway. Even if a route were added, doing so would not enable proper NAT behavior and would not prevent inbound connections from the Internet. AWS Direct Connect establishes a dedicated private network connection between an on-premises data center and AWS, and does not provide Internet access for private instances within a VPC. VPC peering connects two VPCs to route traffic between them privately within AWS. It does not extend Internet access unless the peer VPC performs additional NAT, adding unnecessary architectural complexity and indirect dependency. Ready. Question 20. The wording narrows the answer. Wingtip Toys is finalizing their cloud architecture design. The CTO describes two system behaviors. System A experiences a brief service interruption while failover mechanisms activate and traffic routes to healthy resources. System B continues serving all user requests with no detectable interruption even when an underlying component fails. Which statement correctly distinguishes these two systems? Select one. Review the answer choices on screen. The correct answer is option B. No detectable interruption, fault tolerance, not just HA. High availability means minimizing downtime so that services recover quickly from failures with minimal user impact. A brief interruption during failover is acceptable. System A is consistent with a high availability design where brief recovery periods occur. Common HA patterns include RDS multi-as deployments, auto-scaling group instance replacements, and elastic load balancing health checks, all of which involve some failover time. Fault tolerance means zero perceived interruption. The system continues functioning seamlessly even when a component fails, with no detectable downtime for end users. Fault tolerance requires more redundancy, active component configurations, and is more expensive to design and operate than high availability. Elasticity refers to the ability to automatically scale compute resources up and down in response to demand changes. This is distinct from how a system handles component failures and has no bearing on availability during failure events. 3 takeaways from this session. First, MemoryDB commits every write to a multi-as transaction log before ACK. Elasticache never guarantees that second shared responsibility answers must hold true simultaneously for every service named in the question. Third, a brief failover window signals high availability. Zero detectable interruption requires fault tolerance. Whether it's patching, key custody, or surviving a node failure without blinking, you've now seen exactly where the lines are drawn. Carry that precision forward.